Problem number 40. We're dropping a ball from a state of rest, and we want to compute average velocity over some time intervals and estimate the ball's instantaneous velocity. So the idea here for average velocity is that it's going to be S of the, if S, S is going to be our position here. S of t is 16t squared. So it's going to be S of the end time minus S of the initial time divided by the end time minus the initial time. And we're going to do that for 3 separate time intervals here. 3 to 3.1, 3 to 3.01, and 3 to 3.001. And so for, let me say here, for the interval from 3 to 3.1, this calculation is going to be, so 16 times the end time, 3.1 squared, minus 16 times the initial time, 3 squared, divided by 3.1 minus 3. And so this expression here gives you the average velocity on the interval from 3 to 3.1. If you crunch this out and simplify, you end up with 96.16. Now for 3 to 3.01, now we plug in 3.01 in for t. 16 times 3.01 squared minus 16 times 3 squared divided by 3.01 minus 3. And you crunch, you should get 96.016. And then for the interval from 3 to 3.001, you get 16 times 3.001 squared. You get that plus, minus 16 times 3 squared over 3.001 minus 3. Crunch, 96.0016. So what is happening here, 96.16, 96.016, 96.0016, this is pretty strong evidence that this is going to 96. And in fact, if you do this formally with limits, you can show that the limit here of 3 plus h is exactly equal to 96. So that's what's going on here in problem number 40. For problem number 41, calculate these limits or show that they don't exist. So for the first part here, we have the limit as x goes to -1 of 4 minus square root of 16x plus 32 divided by x plus 1. I see a square. First off, let's plug in -1 here. Plug in -1, we get a 0 in the denominator. Upstairs, square root of 16 times -1 is -16. -16 plus 32 is positive 16. Square root 16 is 4. 4 minus 4 gives us 0. So we're in a 0 over 0 indeterminate form. How do we handle this? Let's multiply top and bottom by 4 plus the square roots, 16x plus 32. Okay, why do we do this? Well, the denominator is we're just going to leave it as x plus 1 times 4 plus square root of 16x plus 32. The numerator, this is a minus b times a plus b. It's of this form, and so it's going to be a squared, 4 times 4 is 16, minus b squared. The square root of this times the square root of this is just that, without a square root. Okay, so this is what we have here. We can simplify the numerator. We can simplify the numerator as this is 16 minus 16x minus 32, or negative 16x minus 16. And so this is, if I factor out negative 16 from that, negative 16 times x plus 1 over x plus 1 times 4 plus the square root of 16x plus 32. So what's going on here? Those cancel. That's the benefit to doing this calculation here, that we can cancel those x plus 1 factors. And we're just left with the limit as x goes to negative 1 of negative 16 over 4 plus the square root of 16x plus 32. And now this is a place where we can evaluate this by plugging in negative 1, by substitution. So negative 16 over 4 plus the square root of 16 times negative 1 plus 32. And so negative 16 over 4 plus 32 minus 16 is 16. Square root of 16 is 4. Crunch, crunch, crunch. If I did the simplifications right, we get negative 2 there. Okay, for part B, limit as x goes to 3 of g of x, where g of x is defined in this piecewise way. So what's going on here? What we need to do is that really what we're going to do is that we're going to compute the limit as x goes to 3 from the left of g of x. We're going to compute the limit as x goes to 3 from the right of g of x. And we'll use that to discuss the limit as x goes to 3 of g of x. So the limit as x goes to 3 from the left of g of x, so this is, we're dealing with values of x a little bit less than 3, and that would be this first case here. So the formula for g of x is going to be x minus 3 over x cubed minus 9x. If we plug in 3 into the numerator and denominator, we get 0 over 27 minus 27, 0 over 0. So we need to do some factoring here to manipulate this. So the point here is x cubed minus 9x. We can factor out an x. So x times x squared minus 9. X squared minus 9, this is the difference of two squares. X times x minus 3 times x plus 3. So this limit here is equal to the limit as x goes to 3 from the left of x minus 3 over x times x minus 3 times x plus 3. Those cancel. And we're just left with the limit as x goes to 3 from the left of 1 over x times x plus 3. And this is, we can substitute in x is 3 now. 1 over 3 times 6 is 1 over 18. Okay, so we found the limit as x goes to 3 from the left here. Now, what about the limit as x goes to 3 from the right? And so the formula here, limit as x goes to 3 from the right of x minus 2 over x squared plus 9. And so no, if x is going to 3 from the right, x is bigger than 3. So that's why I'm choosing the part of this that applies to x is strictly greater than 3. And this is the case where we plug in 3, we get 3 minus 2 is 1 over 3 squared plus 9 is 18. We can just evaluate this by substitution. Nice and easy. 3 minus 2 over 3 squared plus 9 is 1 over 18. So the limit as x goes to 3 from the right is also 1 over 18. So because the limit from the left equals the limit from the right as x goes to 3 of g of x, we say that the overall limit exists and the overall limit is equal to 1 over 18. Okay, so we calculated this limit here. We calculated this limit. You might be wondering, there's one thing here that we did not use at all. The fact that x is equal to 3 is equal to 18. The value of g of x at x equal 3, the value of g of 3 has absolutely no bearing on the limit here. So we did not use the fact that g of 3 was equal to 18 here. If you know continuity, you know this shows that because 18 does not match 1 over 18, our function is not continuous at x is equal to 3. But the value of the function at the point in question has no bearing whatsoever on its limit.